Hello everyone, welcome back to my channel. This is Arun Kashish. In this video, we are going to discuss the methods to find domain of 1 upon fx. 1 upon fx is a real number, and since denominator of a real number is never 0, therefore we discard all the points where f of x is 0. So first of all, we find the points where f of x is equal to 0 and then discard these points from the domain of fx. Therefore, domain of 1 upon fx is given by domain of fx except for the points where fx is equal to 0. Now some examples. First one, 1 upon 2x minus 3. 2x minus 3 is 0 when x is equal to 3 by 2, and 2x minus 3 is defined for all real numbers. Therefore, domain of 1 upon 2x minus 3 is all real numbers except 3 by 2. For this, again, 5x plus 3 is equal to 0 for x is equal to minus 3 by 5, and 5x plus 3 is defined for all r. Therefore, domain of 1 upon 5x plus 3 is r except for minus 3 by 5. 1 upon x square minus 9. Again, x square minus 9 is equal to 0 implies x is equal to plus minus 3, and x square minus 9 is defined for all real numbers. Therefore, domain of 1 upon x square minus 9 is r except for 2 points plus minus 3. For 1 upon x square plus 4, since x square plus 4 is never 0, as x square plus 4 is equal to 0 has no real roots, therefore domain of 1 upon x square plus 4 is all real numbers. 1 upon 2x minus 3 into x plus 1. 2x minus 3 into x plus 1 is equal to 0 for x is equal to 3 by 2 and minus 1. And 2x minus 3 into x plus 1 is also defined for all real numbers. Therefore, domain of the given function is r minus the 2 points 3 by 2 and minus 1. Now next is domain of 1 upon square root of x plus 1. Square root of x plus 1 is 0 for points where x plus 1 is 0, that is x is equal to minus 1, and x plus 1 square root is defined whenever x plus 1 is greater than or equal to 0, but x plus 1 is not equal to 0, so we take x plus 1 to be greater than 0. This implies x is greater than minus 1. So, domain of 1 upon root x plus 1 is given by minus 1 to infinity. Next, 1 upon square root of x square minus x minus 6. First of all, we find points where x square minus x minus 6 is 0. We can easily find out these points. These are minus 2 and 3. Now we plot the rough sketch of x square minus x minus 6. Minus 2 and 3 are the 2 points where the graph will cut the x-axis, and a quadratic function is a parabola. If the coefficient of x square is positive, then it is an upward parabola. So we plot upward parabola. We have discussed these in the previous videos. Now we can see that the graph is above x-axis for the points which are less than -2 or for the points which are greater than 3. Therefore, the points for which the function 1 upon under root of x square minus x minus 6 is defined are given by -infinity to -2 union 3 to infinity, open brackets. Take some more examples. 1 upon square root of x square minus 16. Here x square minus 16 is 0 at x is equal to plus minus 4, and x square minus 16 is a quadratic function with a is equal to 1, so it will be upward parabola cutting the x-axis at 2 points -4 and 4. Rough sketch of this. Now the points where the graph is above x-axis are from -infinity to -4 or from 4 to infinity. So the domain of this function will be -infinity to -4 union 4 to infinity. Similarly, the second one, 1 upon square root of 9 minus x square. Since 9 minus x square is equal to 0 implies x is equal to plus minus 3, easy. Now a rough sketch of 9 minus x square. We plot its two roots on the x-axis, -3 and 3. In this case, coefficient of x square is -1, so it will be a downward parabola. And as we can see, the graph is above x-axis for these values from -3 to 3. At -3 and 3 is equal to 0, we discard these 2 points. So the domain of the given function is -3 to 3 open interval. Next question, 1 upon 2x square plus 5x plus 4. First of all, we check the roots of 2x square plus 5x plus 4 is equal to 0. For this, we can find its discriminant, which is b square minus 4ac. It is 25 minus 4ac is 32, less than 0. As b is less than 0, therefore 2x square plus 5x plus 4 has no real zeros. So domain of 1 upon 2x square plus 5x plus 4 is all real numbers. Now next one is 1 upon 2x square plus 5x plus 4 square root. Again we have checked that 2x squared plus 5x plus 4 is equal to 0 has no real roots. So if we plot graph of 2x squared plus 5x plus 4, it is upward parabola, and it will never cut x-axis, so parabola will always be above x-axis. This means that 2x squared plus 5x plus 4 is always greater than 0. Therefore, domain of our original function 1 upon 2x squared plus 5x plus 4 is all real numbers. Next, 1 upon x squared minus 6x plus 8. First of all, check the roots of x squared minus 6x plus 8. We can easily find these roots to be 2 and 4. So domain of this function will be all real numbers except the 2 points 2 and 4. For the second function, we plot the graph of this function x squared minus 6x plus 8. It is an upward parabola. Because coefficient of x squared is 1 positive. The roots are 2 and 4. Upward parabola. Graph of this is positive for x less than 2 or x greater than 4. Therefore, the domain of our original function 1 upon square root of x squared minus 6x plus 8 must be from minus infinity to 2 or from 4 to infinity. That is, it is minus infinity to 2 union 4 to infinity. Next one, 1 upon minus x squared plus 5x minus 6. Again, we can check that roots of minus x squared plus 5x minus 6 is equal to 0 are x is equal to 2 and 3. So domain of this function will be all real numbers except the 2 points 2 and 3. Now for this second one, we plot the graph of minus x squared plus 5x minus 6. We have found the roots 2 and 3. Coefficient of x squared is, in this case, it is negative. It will be a downward parabola then. Downward parabola. These we have discussed in the previous videos. Now we can see that graph is above x-axis for the points when x lies between 2 and 3. Therefore, the domain of our original function will be, it will be from 2 to 3 open interval